Welcome to Lesson 13 of Unit 2, Solving Systems by Substitution. So previously we have solved systems of linear equations by graphing. Today we are going to learn how to use substitution to do the same thing. So the goals for today are you can solve systems of equations by substituting a variable or an expression, and to know more than one way to perform substitution and can decide which way or what to substitute based on how the given equations are written. So the first activity we're going to do is Math Talk, Is It a Match? This is a warm-up on page 93 of your student workbook. So here are two graphs of two equations in a system. What I want you to do is determine which of these systems could be represented by the graph. Okay, if you chose system C, you are correct. System A does not work because the graph x equals -5 would be on the left side of the vertical axis, which is not what is shown. So this blue line would be over here on the left side. System B does not work because the graph for y equals -1 would be a horizontal line, but no horizontal line is shown. System D does not work because the graph for y equals 2x minus 7 would have a positive slope and a negative y value for the y-intercept. Neither of which match the given graphs. So it would have a positive slope and the y-intercept would be down here, which leaves us with system C. System C works because 3x minus 8 can be rearranged into x equals 8/3. The graph for x equals 8/3 is a vertical line to the right of the vertical axis. So this vertical line to the right of the y-axis would be 3x minus 8. And then 3x plus y equals 15 can be rewritten as y equals -3x plus 15. Its graph has a negative slope and a positive y value for the y-intercept. So we have a negative slope here and a positive y value. So another strategy we could have used to figure this out would be to solve the systems and check to see if the solution matches the intersection point. So today what we're going to learn is how to use substitution to solve these systems of equations. Systems. This is on page 93 of your student workbook. So what we're going to do is we're going to solve these four systems of equations using substitution. We are going to do A and C together, and then you're going to do B and D on your own. Okay. For system A, we have in the bottom here x equals -5. So we are going to substitute in -5 for x in this top equation. So we're going to rewrite this top equation as -5 plus 2y is equal to 8. So again, we just took this -5, substituted in for x, and now we have an equation with one variable. So now we solve. So first thing, we have to add 5 to each side. So that leaves us with 2y on the left side. So -5 and +5 cancel out. It's equal to 8 plus 5, which is 13. Then we divide by 2, and that gives us y is equal to 13/2. Or if you want to write this as a decimal, it is 6.5. If x is equal to -5, y is equal to 6.5. So now we need to go back and check our work. So we go back to this top equation, x plus 2y is equal to 8. And we need to substitute in x and y. So -5 plus 2 times 6.5 is equal to 8. So we're left with -5 plus 13 is equal to 8, and 8 is equal to 8. So we're good there. Okay, now we're going to try C. Now the first thing that we notice about C is that there's no isolated variable. There's no x equals something or y equals something within one of the equations. So we can do two things. The first thing we can do is rewrite this top equation as x is equal to 8/3. Or we notice that in this bottom equation, we have a 3x, and in this top equation, we have a 3x equals 8. So what we can do is just substitute this 8 in to this bottom equation for the 3x. So that will look like 8 plus y is equal to 15. So again, we took this 8, that's equal to 3x, substituted into this bottom equation for 3x. And now we solve. So first we have to subtract 8 from each side. So minus 8 is equal to 15 minus 8. We're left with y is equal to 15 minus 8, which is 7. Now we need to solve for x. And again, from this top equation, we know x is equal to 8/3. So we have x is equal to 8/3. Y is equal to 7. But again, we have to go and double check and make sure. So we take our bottom equation here. So 3 and 8/3 in for x plus 7 for y is equal to 15. We're left with 8 plus 7 is equal to 15. 15 is equal to 15. So we're good here. Now that we have done A and C together, I want you to try B and D on your own. Here are the solutions for the first activity. Pause your screen now to check your answers. One thing to notice about solving for systems of equations is that there's always multiple ways to get to the same place. For example, in C, you could have solved for x, so x is equal to 8/3 in the top equation, and then substituted in 8/3 in for x into the bottom one. Or even for D, you could have solved for y in the bottom one, so y is equal to 8, and then substituted in 8 for y in the top. All of these methods work. You choose which one is best for you. We're going to move on to the next activity. What about now? This is on page 94 of your student workbook. What I want you to do is I want you to solve each system without graphing. Use that substitution method that we've been talking about. We will go over some of these examples next. Okay, let's walk through this example. So step 1 is we need to substitute in 2m plus 10 for p. So that looks like 2m minus 2 times 2m plus 10. So here we need to be careful. When we are distributing this 2 into 2m and 10, we need to distribute this negative along with it. So what that looks like is 2m. Negative 2 times 2m is a minus 4m. Then negative 2 times a positive 10 is a minus 20. So again, we have to distribute this negative along with the 2. And that is equal to negative 6. Then we simplify. So we have a negative 2m minus 20 is equal to negative 6. So negative 2m minus 20 plus 20, add 20 to each side. That leaves us with negative 2m is equal to 14. Divide by 2, negative 2, sorry, divide by negative 2. M is equal to negative 7. So next we need to take this and substitute it back into the original to solve for p. So p is equal to 2 times m, which is negative 7. Plus 10. P is equal to negative 14 plus 10. P is equal to negative 4. So we end up with P is equal to negative 4, M is equal to negative 7. Make sure we substitute our answers back into the original to make sure that we didn't make any mistakes in our process. Okay, let's do one more example. With this, we notice we have a 2D in the top and a 2D in the bottom already. So we can take 8F, substitute in for 2D in the bottom. And that is going to look like this. Now we solve for F. So first what we're going to do is add a 4F to each side. Then we are going to divide by 12 on each side. So F, so 18 over 12 is equal to F. So F is equal to 3/2. Now we take these 3/2, substitute it back into the original. So 2D is equal to 8 times 3/2. And then we solve for D. So we have D equals 6, F equals 3/2. And again, make sure we are substituting this into the original equation to check our work. Just like with the last activity, there's multiple ways to arrive at the same place when solving systems of equations. Just because you don't have the way that I used here does not mean your way is incorrect. Now is your chance to pause your screen and compare your work. Sometimes substitution isn't always the easiest way to solve a system of equations. Which one of these systems would be easiest to use substitution to solve, and why? Which would be the most difficult, and why? The system that would be easiest to solve would be system 2. We already have a variable that's isolated, so all we would need to do is substitute in negative 2x plus 9 in for y, and then solve for x. The system that would be most difficult to solve would be system 3. There's no isolated variable. Each variable has a coefficient. It would take a lot of rearranging to get this where it needed to be to use substitution to solve. Here are today's goals again. Make sure you complete the cool down at the end of this lesson.